Hey, so this video is in response to your email. I'm going to quickly show you what I mean by my corrections. I think it's best to sort of show you by visual as opposed to try to explain it in words because it's hard to talk about its reaction when you haven't seen it. So for my first correction, question 1, you were given 3,4-dibromohept-1-ine. And so the drawing is correct, right? So this is the first carbon, this is the second carbon. So you have 3 and 4 with bromine, I guess, substituent groups. What I meant by the negative 0.5, so I took a half mark off because you didn't show the proper configuration or proper 3D orientation configuration for a triple bond. If you remember, if you have a triple bond between two carbons, we would have a sigma, a pi, as well as a pi, right? In other words, we have, you could think about it as a bond way up top, like an archway, way in front, popping out of the page, like it was a hula hoop, and another one in the back side that you can't really see, which means it leaves all of this empty space on the edges, on the left and right edges of each respective carbon for your bond. But that bond doesn't form here or doesn't form here. No, it forms as far away from the other electrons as possible. And so the bond would be here and here. If I were to take all this and try to draw it in a stick form, you would see a carbon triple bonding, and the hydrogen would be perfectly parallel with the triple bonds and perfectly parallel on the other side with the other carbon. Long story short, this drawing should have been that would be first carbon, second carbon, third carbon, 4, 5, 6, 7. 1, 2, yeah. So let me try to make it neater. This is my first carbon that has a triple bond with my second carbon here, which should have a linear connection with the third carbon. And then for the third carbon is not limited in geometrical orientation. It could have 3 bonds in the tetrahedral shape, right? And so this would be 4 carbon, 5 carbon, 6 carbon, and 7 carbon. The third carbon would have the bromine, or if you so choose, it would be up here, bromine, and the fourth carbon would have a bromine. That would be the correct answer. So that was a 0.5 mark off. Okay, let's move on to question 2 while I erase it. I'm going to quickly talk. I just need to, sorry, maybe I should just leave that there for your viewing pleasure. I just need some space to talk a little bit about question 2 and 3. For question 2, everything was correct. You're actually correct, but the only reason why I took a single mark off was because you made a simple mistake. How many carbons do you see? I see from here, this is the O, so that doesn't count as a carbon. This is your first carbon. That's your 1. That's your 2. That's your 3. And that's your 4. Phenyl is correct. Pentanol is correct. And you didn't put a 1 there because, because you use all as your main carbon backbone chain, you can sort of assume that the 1 is where the alcohol is. It's sort of convention. If you don't put the number in there, but there is something special going on, we assume as chemists that you didn't put a number because we assume that's your 1, which means 1, 2, 3, your phenyl should be in the third position. That's all. So that was 1 mark off because that was a simple mistake that you shouldn't have made, and so unfortunately you were punished partially for it. Okay, question 3. I think I marked this incorrectly because I thought you were doing a different reaction. I see now that you were doing, it didn't label. We didn't label this on, sorry, we didn't label this on your Jamboard, but that was a number 2. Okay, so if your question was number 2, then you had to create this molecule in 2 different ways. So now I get it. Your first reaction is correct. If you have a carbon-carbon chain that way, the double bonded carbon, the 4 electrons here as you saw before, if you make a carbon-carbon double bond, we have a sigma and a pi bond that is sort of difficult to hold on to without using a certain amount of energy, right? So this is sort of semi-unstable, and if we can, we would love to have a single bond. So the electron pair here will want to bind with something, right? And of course, we know that Br is relatively electronegative. It wants that electron pretty badly. These double bonded carbons, they're like, hey, if you want to take my electrons, go ahead. And so we start, what am I doing? We start a reaction process. And so this creates CBr, and one of these double bonds lines will disappear. So that is correct. The second one, I think what you were doing is you were taking a regular alkane and you were taking a hydrogen and a hydrogen and you were hoping to swap out one hydrogen with the Br. Number one, that can't happen because after all, bromine is diatomic. It wouldn't be single. So if this was Br2, where does the second bromine go? Secondly, this reaction where you simply swap, bromine, although it's electronegative, does not have the, I guess, aggressive electronegative strength to actually kick off the hydrogen and take the electron that carbon was bonded with. Okay, so the first reaction is correct, so I'm awarding you 2, so the mark has been updated, but the second reaction is impossible. There is no such thing as a reaction with a single bromine. Okay, if you specify, again, in university level, if you specify that this was a bromine radical, that's something you will learn probably, we might have learned in class, or if we didn't have the isolation period. It's basically saying a bromine was happy with another bromine, but because of some kind of catalyst or an input of energy or maybe UV from the sun, the bromine was broken. So bromine's like, hey, I'm super unstable. Hey, I'm super unstable. I want an electron. I want an electron. And instead of getting back together, bromine happened to find the middle carbon out of the entire butane chain. And that can happen, but number one, it's not common per se unless the conditions are perfect. And number two, the way you drew your reaction or wrote down the reaction is in fact incorrect, right? And I wouldn't expect you to know radical, so it's hard for me to say this was what you meant unless you told me that you knew what you were talking about. So there's the 2 marks out of the 4. Hope that explains everything. You're not doing a bad job. Don't be necessarily disappointed with what you have done. Organics is a lot more complex than you think. Although the system is set and all you think you have to do is memorize, no. In fact, after the memorization comes a gazillion ways to apply it. So keep working at it, and hope you finish strong. See you soon.